Hey guys, today we're going to talk about parallel and perpendicular lines. Today's lesson is going to be a little bit different. The work is already completed. I do want you to go through and complete this in your notebooks or on the PDF. So make sure you are showing your work on either one. So the goal for today is to use slope to determine whether two lines are parallel or perpendicular. So the first thing, parallel lines are two straight lines that will never intersect. Okay, and here's an example of what those would look like. They could be spaced out further than that. And in order for them to be parallel, they each must have the same slope. So you'll notice I have an example of y equals 2x plus 1. The slope is 2. The other line is y equals 2x minus 6. The slope is also 2. So this is how you can identify that these two lines are parallel. It does not matter what their y-intercepts are. Perpendicular lines are two lines that meet or intersect each other at right angles. And remember, a right angle is at 90 degrees. So they come together and kind of make an X or a T. Each one of these is a 90-degree angle. And what's different about their slopes is they are negative reciprocals of each other. So for instance, if I have this slope 2, in this equation, y equals 2x minus 1, the slope is 2. If I wanted to find a line that is perpendicular, or to check to see if a line is perpendicular, I would need the negative reciprocal of this. So remember, there's a denominator here that's kind of hiding. If you don't see it, there's a 1 underneath. Reciprocal means to flip it, and a negative reciprocal just means change the sign. So if it is positive, it'll turn into a negative. If it already is negative, it'll turn into a positive. So when I flip this and find the negative reciprocal of it, it becomes negative 1/2. These two are perpendicular and will come together and create 90-degree angles. All right, example 1. You're going to find the slope of a line parallel to the given line and the slope of a line perpendicular to the given line. So just like we've been doing, you have 2 points. Point A is -2, 5. Point B is 0, -1. You're going to use your formula to first find the slope between those 2 points. Okay, so that's where we labeled our x1, y1, x2, y2, and substituted in. So y2 minus y1 over x2 minus x1. Simplify your numerator. -1 minus 5 will be -6. Divided by, simplify this denominator. Be careful with the double negative. Some of you are just writing -2 rather than -2, and that is where your answers are becoming incorrect. Make sure, write this step out so you don't have that error. So -6 divided by 2 is -3. So that is the slope between these 2 points. To determine if it's parallel, we need the same slope. Okay, so parallel, my slope will just be -3. And perpendicular, remember we want the negative reciprocal. So this is my slope. I want to flip my fraction and change the sign. So when I flip my fraction, it turns into 1/3. It was negative, now it is positive.
Serenity, Rigatero, please come to guidance. Serenity, Rigatero, please come to guidance.
This second example, same process. Go through, substitute your points in, or your values in. And you will get 0 over -9, which equals 0. This is the slope of your line. Okay. You could think about it like there's a 1 underneath the 0 if you want to. When you find the negative reciprocal of that, it turns into a problem where you're dividing by 0. Dividing by 0 can never happen, so it is undefined. And here's kind of a sketch of what that would look like. Okay, so this would originally have a slope of 0, it would be a horizontal line, and then perpendicular, straight up and down, and that has an undefined slope, which is also shown right there. All right, example 2, you need to determine whether each pair of lines are parallel, perpendicular, or neither. In order to do that, you need to get both of these equations into slope-intercept form. Okay, so this first equation I'm manipulating over here. The second equation on the right-hand side. So what you're going to do is you're going to subtract 7x from both sides. So you get 2y equals negative 7x plus 14. Then you're going to divide each piece or each term by 2. So you will get y equals negative 7 halves plus 7. Do the same thing with the equation on the right. So on the right, the goal is to get y by itself. So you're going to divide each term by 7. So you're left with y equals 2 over 7x minus 5 over 7. So you're going to compare these two slopes. This slope is a negative 7 halves. The other slope is a positive 2 sevenths. So they're opposite signs. That meets part of the criteria we need. And they're also reciprocals. So therefore, these two lines are perpendicular. The second one, the same idea. You're going to go through and put it in slope-intercept form. So you can see I added 5x to both sides. 3y equals 5x plus 2. Divide each term by 3, and you're left with y equals 5/3 x plus 2/3. The second one, 3x minus 5y equals 15. Move your 3x over, divide by negative 5, and you're left with y equals 3/5 x minus 3. Looking at your two slopes, you'll notice that they are reciprocals, but they're not negative reciprocals. So therefore, it is neither.
Attention students, the upstairs dining hall is now open. The upstairs dining hall is now open.
And example 3 is right here. You can follow all the same steps. It's the same process as before. Here's the slope. Here's the other slope. They are the same slope, therefore they are parallel lines. Take a minute and actually look through this map and complete it yourself. Example 3. It tells us our slope is negative 2. It gives us 2 points, but you'll notice we're missing the x coordinate. So these are the ones that we did the first couple weeks of school where we have to go through and find or solve for x in order to determine what the slope will be. So we want a line that is parallel. So because it is parallel, we're looking for the same slope. So we can use the slope that they've provided. Label your points, substitute into your formula. So you'll get 6 minus 9 will simplify to negative 3. Negative 5 minus x. Remember, you can't put those together. They're unlike terms, so that'll just stay the same. You're going to cross multiply. So it'll turn into negative 2 times the quantity. This got a little messy here. It says negative 5 minus x equals negative 3. Distribute your negative 2 to each term. So 10 plus 2x equals negative 3, and then solve. So your x value is negative 13 over 2. It is okay if you get decimals. It is okay if you have fractions. It is okay if they're improper fractions. Just make sure you simplify them whenever possible. Do not change these into mixed numbers. Number 14 is very similar to number 4 is very similar to number 3. Except for this one, you want to find a line that is perpendicular. Okay, so you can't just set it equal to the slope like you did up here, equal to the provided slope. This one, you have to manipulate it, or you have to find the negative reciprocal before completing the problem. So your slope was negative 1/3. We want to flip it and change the sign. So it becomes 3 over 1 or just 3. That is what we're going to set our equation equal to. Then you're going to substitute your values in. Make sure you put these in the appropriate locations. Y2 minus Y1 over X2 minus X1. I'm showing you down below how to work with those fractions if that's what got you, and you need to find a common denominator. You can find that by multiplying the numerator and denominator by 2. When you add, you add across the numerator, the denominator remains the same, and simplify. So that is where this 3/2 is coming from. Then you will cross multiply, which is shown here, and solve. All right, have a good day. Email me if you have any questions.